Hey y'all, in an effort to kind of help you out with the assignment, I'm about to go over a few specific examples from 4.3 topic, Unit 5, Topic 2 assignment. So if you are on Canvas, I'm going over this one right here, if you want to click that one. And I'm going to pick maybe 4 or 5 problems to go over. So let's preview that. And I'll toggle back and forth between my my writing so you can see me work out some things, and I'll put up Desmos. All right, see, I did this earlier. This is just following the pattern. Figure out what it's being multiplied by. So what times 3 is equal to 12? What times 3 is equal 12 is equal to 48. It should be the same number. What times 48 is equal to 192? And you should figure out that pattern and move it. It says g of 10, so just go to g of 4 would be whatever 192 is times 4, and so on. Bring it all the way to 10. Question number 2. Which transformations map the parent function y equals 3 to the x power under the new function y equals 3 to the x plus 4 minus 6? So in the exponent, when it's being added, it's left. When it's being subtracted, it's right. It's the opposite of the x-axis. Because you know on the x-axis, right is positive, left is negative, but with the x transformations left to right, it's always the opposite. So this will actually take it left 4, and minus 6 will shift it down 6. Okay, 3. Population of a school has 2,100 students and has been decreasing at a rate of 3.8% each year. So on that one, oops, I lost my camera, hold on. So it is starting at 2,100 and decreasing at a rate of 3.8% per year. So what you're going to do to set up your problem is you'll do capital A equals lowercase a parentheses 1 minus the rate because it's decay to the t power. And since the starting amount is 2,100 and the rate is 3.8%, which 3.8% as a decimal is 3.8 divided by 100 is 0.038. Subtract that from 1. And whatever this number is in here will basically determine your answer. So subtract that, that'll get you this number, and then you'll have your answer choice you can pick from. All right, let's look back at the problems. So those should be the review. Okay, so this is the new stuff. So let's look at question number 4. And I'm gonna go over maybe a couple of these, and there's a lot of repetitiveness on these problems, so I'm not gonna go over a ton, but let's look at number 4. And we'll work this one out and actually come to the answer. So the question says, what is the logarithmic form of 9 squared equals 81? We have some answer choices. So I'll go back to just my paper and pencil so you can see what's going on. So 9 squared equals 81. To write it in logarithmic form, you're going to write log. All logs have a base. So there's going to be some number here, some number there, and it's going to be equal to some number. The number that's in the little subscript in the base of the log is always the number that is in the base of the exponent. So whether it said 81 equals 9 squared or 9 squared equals 81, whatever is being raised to a power is the number that's going to be written small right down there. Now, as far as these other two numbers, they're really just going to switch spots. So you know how the 2's with the 9 here? Well, it's going to be over here now. And that means the 81 is going to be there. So you just kind of split them up. And the way you read that is 9 squared. You kind of go out, and then you come back, equals 81. So it should be log base 9 of 81 equals 2. All right, let's look at a couple more. Let's see, 5. 5's a lot like that, so I'll leave that one alone. 6. 6 is like it too, you just got to be careful. So, you know, your base in this case is 1/4. That's your little subscript. So it's going to be one of these two here. Remember to split these up. 7. So just real quick, going back from log to exponential, I'll write this one out. Log of 10 equals 1. Well, there's no base written. So in a log form, if there isn't a base provided, that's just a base 10. That's the default base. So if it's not written there, then we substitute that in. So that's really 10 to the first power equals 10. 10 to the first power equals 10. Which is true. 10 raised to the first power is equal to 10. Absolutely true. All right, let's do a couple more. Let's see, 8. Ooh, 8's a big one. I can do a couple of these. So on this problem, I'm not going to write it out. I'm just going to kind of show you what's going on here. So it says match each of the exponential equations with its corresponding logarithmic equation. Match up the letter to its corresponding number. So you go down here and you're like, A, B, C, D, E, F, or whatever, and only one goes to each one. So 3 to the x power equals 5. So what I look for on question number 1 is 3 is your base, right? So I'm going to go over here and I'm going to look for which log has a base of 3. That log has a base of 5. That log has a base of x. C has a base of 3, and so does D. So it's going to be one of those two. So now I want to be able to split this up. So 3 to the x equals 5. Remember, in the log form, these are going to split. These are going to go on the other side. So the x will be on the opposite side of the equation in the log form, and the 5 will be in the log. So on number 1, 3 to the x equals 5, you actually want to pick log base 3 of 5 equals x. So 3 out to the x power, come back equals 5. 3 to the x equals 5. So it's going to be D. I don't know if your answer choices are scrambled, but this one goes to this one. Let's do maybe one more. I'll do maybe 2 or 3 on this. So 5 to the x power equals 3. So what's your base here? Is it 5x or 3? Well, it's 5. So go over to the log and find the base that has 5. A has a base of 5. And so does E. So it could be one of those two. Now I want to split up the x and the 3. So we don't want the 5 with the x here. So it can't be this one. Well, so excuse me. It can't be this one because 5x here, that's not the same as 5 to the x power. So it's going to be the first one because the way you read letter A is 5. You go out to the other side to that power. And then you come back and you say equals 3. So this is 5 to the x equals 3. It's just a pattern. So 2 is going to be A. And I'll do number 4. So 4 is x to the 5th equals 3. Which one is the base, x, 5, or 3? Well, it's going to be x. So let's go find one that has a base of x. Well, B has a base of x. So does F. So let's see. X to the 5th power equals 3. So this would be x to the 3rd power equals 5. And this would be x to the 5th power equals 3. So 4 is going to be F. So hopefully you understand kind of the process there. It's just kind of repeated. It's a pattern. That's question number 8. So that was kind of the big one. That's why it's worth 6 points. Let's look at a couple more. 9. Okay, so 9 and 10. I think 10's similar to that. Yeah, we'll do 9 and 10. So 9. You don't want to actually solve anything. So what you want to do on number 9, I'm going to write 81 equals 3 to the x power down. Okay, so let me go back to the rest of it. We want to write it in log base D of E equals F. Log base D of E equals F. Log base D of E equals F. We want to assign to D either 81, 3, or X. To E, either 81, 3, or X. And to F, either 81, 3, or X. Only one goes to each blank. So let's look at how do we do that. Well, again, it's very similar to the last problem. We want to basically rewrite this in log form, but when I'm writing that in log form, you got to identify your base, right? So is 81, 3, or x the base of this problem? And the base is going to be whatever is being raised. So the base in this case is 3. Well, let's look at the log form. Which is the base, D, E, or F? Well, you're right if you say 3, if you say D, so that's going to be 3. Now let's look at E. E is what's in the log. Remember that when it's converted from exponential to log, we actually split these up. So the 3 is not going to go with the x in the log form. It's going to go with the 81. So that E will be 81, and the F will be x. So the way you write that is log base 3 of 81 equals x, and then the way you convert that from log to exponential would be 3 to the x power equals 81, which is the same as 81 equals 3 to the x power, same thing. And I think 10 is very similar. 10 has it the other way. So in this case, you're going from log to exponential. So I'll do 10 with you, why not? So it's going to be log base 8 of x equals 3, and we want to get it to d to the e power equals f. Identify d, e, and f. So again, I'm going to go back to my paper. So log base 8 of x equals 3. My base is going to be 8. So my base and my exponent is going to be 8. That's going to be d. That's usually the easiest one to get. Now remember, exponents and the equation, they get separated. So d to the e power would be 8, not to the x power, but 8 to the third power. So d to the third, so it'd be 8 to the third power. And then we come back and we say equals what's in the x, the log. In this case, it's just x. So 8 to the third power equals x. So it'd be 8, 3, and x. So basically, it's like kind of go in order, 8, and then switch these up, 8, 3, and x. All right. Let's see, 11. So 11 through, gosh, how far does it go down? 13. A lot of these are going to be like that. Pretty much all the way to the end, I think, right? Well, except for the last couple, those are transformations. Let's start at 11. So you get to a problem like 11, and you want to do evaluate log of base 2 of 128. First of all, evaluate means to give me a number. I don't want you putting equations in here. I want to know what is that number. So the way you do this in your head or just by hand would be to think about what number can I raise this base to get 128? What can I raise 2 to, what power, to give me 128? That's how you interpret number 11. And a lot of the questions after that, although this 11 is the easiest one probably. So let me write that down and do a couple harder ones too. So the interpretation of log base 2 equals 128 is you got to think about what number can I raise 2 to give me 128? Once you figure out that number, that is the answer to this, okay? So 2 to what power is 128? I mean, that at that point is, it could be trial and error if you want. 2 to the 5th power, that's 32. So that's too small. 2 to the 6th power is 64. 2 to the 7th power is exactly 128. So your answer is actually just going to be 7. All right, 2 to the 7th power is 128. And we don't write, I don't want you writing in there this. I want you telling me what that equals. So your answer is going to be 7. Now you're going to do that. You're going to be doing a lot of extra work in your head if you sit there and just think about all these, because some of them are going to be decimals or fractions. So what we'll do is on Desmos, you get Desmos loaded up. Take a minute to pause video if you need to, get Desmos pulled up. I'll show you exactly what to type, okay? You're going to type log, like you're spelling the word log. Notice that it went from italic to regular font, so that means that that's an operation. Then you're going to hit together. You're going to hit, sorry, I'm looking at myself, but looking at you. You're going to hit shift. Then you're going to hit the minus button next to the 0. That gives you a base to pull down. Type in 2. Then you're going to hit the right arrow. Then you can put your 128. Use parentheses if you'd like. Same thing. 7 is your answer. You can do a lot of these just like that. Don't tell anybody. So how do you get that if you don't want to use your keyboard? Go down to the math. Pull that up, go to functions. Trig, stats, distribution, miscellaneous. Click miscellaneous. Log, that's base 10. Log A. So I'm going to click log A. Voila. 2, right arrow, 128. So if you really don't want to type log and underscore and all that stuff, there's the other way to do it. That basically will get you from 11 to 19, and then the last couple are transformations. Let me just pick a harder one to do, and we'll move on from there. So that's 11. So you know the answer to that is 7, right? You just type 7. Let's pick a harder one. Okay, that's not hard. Let's say 14 maybe. Did I just click 14? Let's try 17. Well, it looks hard. 17 is really not that bad. Let's try 16. Oh, you can do 16 in your calculator. 18. There we go. All right, 18 looks difficult. Log base 3 of 1 over 81. How the heck do we do that? Well, I'll show you by hand. So first of all, what is that? What is that? Number 18. I already forgot. My brain's fried already. Log base 3 of 1 over 81. Log base 3, 1 over 81. All right, so if you're doing this in your head or by hand or without trying to cheat, it's not really cheating if you're using the calculator, but if you're without trying to have the calculator tell you the answer, you think about 3 to what power is equal to 1 over 81. And before we even think about, well, I can't get a fraction, yes you can, a negative power gives you a fraction. And what you can do is you think about 3 to what power gives you 81, all right? You can get 81. 3 to what power equals 81? 3 times 3, that's 9. All right, 3 to the second power is 9. 3 times 3 times 3. 9 times 3 is 27. So 3 to the third power is 27. So 3 times 3 times 3 times 3, 27 times 3 should be 81. 3 to the fourth power, 81. Okay, next step. 3 to the fourth power is 81. Great. Now what? Okay, so 1 over 81 is going to be thought of as 1 over 3 to the fourth power. Now, when you want that fraction gone, you just say 3 to the whatever is equal to 3, and if you bring it up, make it negative 4. So now that I have the same base, what number equals negative 4? Well, the answer is negative 4. 3 to the negative 4 is equal to 3 to the negative 4. You want the same thing on both sides of the equation. So that's going to be equal to negative 4. Now, if you don't want to go through all of that riffraff, you can type in this. You would say log shift underscore 3 right arrow parentheses 1 divided by 81, right arrow close parentheses. And your answer is negative 4 right there. No questions asked. You have the answer. Done. All right. And before I get other questions about other things, let's look at this one here. All right. Log base 7 of 7 to the 6th power. I mean, you can put in your calculator if you need to, or you can do 7 to the 6th power and evaluate that. There are ways to get that done. I think 16 was the one I was wanted to go back to look at. So when it does not give you a base, all right, when it says log of 100,000, you know what you're doing on that problem, log of 100,000. If there's no base, then don't worry about typing the base. Log of 100,000 is 5. Now, why is there no base? What is the base if it's not written? What's that default base for log? Think about it. What to the 5th power gives you 100,000? Is it 10? 10 to the 5th power, 10. 0, 5 zeros to the 5th power is 100,000. How many zeros are there? 5. Make sense? 10 to the 5th power is 100,000. The answer to that is 5. You can put it in like this, you put it in like this. Same thing. The answer is 5. So that leaves us with the last couple of the transformations, 20 and 21. We'll do 20. All right, 20 and 21 are similar. Talk about transformations. We want to know what happens when I multiply the outside by a number between 0 and 1. Does it reflect? Well, it doesn't have a negative. So guess what? Not going to reflect. Let's see, between 0 and 1, does it stretch or compress? Well, multiplying by a smaller number should make it smaller. So not stretching, because that's good. Stretch makes it taller, makes it bigger. So compressing is a number between 0 and 1. 0.3 is between 0 and 1. That's going to compress it. Yes, but it won't stretch it. Can't compress it and stretch it at the same time. That's impossible. So it's going to be compressed, not stretched, not reflected. Now in here, notice that x plus 4, when it's going in the parentheses of log, remember that's right or left. So x plus 4, well, right or left is the opposite, right? So it's not going to be right 4 because the x-axis works backwards. So it's going to be left 4. Will it go right? No. If it's going to go left, it's not going to go right. But there's no number being added at the end. So is it going to go up or down? No. Doesn't go up. Doesn't go down. Now graph it. All right, log base 5x. Y equals log base 5 of x. Just take a look at that problem for a minute. Okay. It's like exponential, but it's reflected over this line. All right, it's an inverse of exponential. Now it's going log base 5 of x. Now if I want to shift that, well, if I want to compress it, multiply that 0.03 at the beginning, 0.3. Oops, you know what I want to do? I'm going to leave that there. I'm going to go y equals 0.3 log base 5 of x. Guess what? It made it flatter, compressed it. Let's say it was 3. Stretched it. 0.3, compressed it. Negative, reflects it. All right, I want to take this x plus 4 in the parentheses. So now let's bring this to the left 4 by doing x plus 4. Oh, and it shifted it to the left. You see that? If I did minus 4, it shifted to the right. But that's it. It didn't go up or down. There was no number being added to the end or subtracted to the end. It's staying put vertically. So it's only going to be compressed in left 4. Compressed and left 4. So there's a lot of no's here. Anyway, I'm going to be done with this. That's plenty of examples for you to work with on this assignment. You know, I went over a good chunk of it. I hope this was helpful for you. Please reach out if you have any questions. Remind, email, Canvas, whatever. Bye.